So this is a phase shift. A phase shift I know because it's this. Because normally if I see a function and I see this, I know that it's a horizontal shift the opposite way, right? By 2 units. Now our problem with this is by angles. So even though it's a horizontal shift, we just call it a phase shift because you're changing angles. So again, identify the A and the B first. There's your A. Here's your, God bless you. It's, even though it's a fraction, it's greater, God bless you, it's greater than 1. So because it's greater than 1, it is a stretch. It is a vertical stretch by a factor of 5 halves. If it's a fraction and the numerator is smaller than the denominator, it is a shrink. If the numerator is larger than the denominator, it is a stretch. This is the only thing that's going to affect your range here. Okay, domain, we know domain. Frequency is 1. Now all we got to do is take this guy and move it the opposite way, and we do C over B, but in this case B is 1. So we're just going pi units to the right. So that's all we have to say. So instead of starting this at 0, this is a sine curve, we're going to start it here at pi. The frequency is 1, so it's just going to go 0, 5 halves, 0, negative 5 halves, 0. And you're just going to back it up the other way, because of course this is a continuous curve. So if you had to graph this, this is what it's going to look like. And did I ask you to graph this? No. The only thing that you would need to know is where is one complete phase. And we usually start all our graphs from quadrant 1 because that's where we start the unit circle. So we're going to say if this was equal to 0, or because normally wouldn't my period be 2 pi for this? Because there's a frequency of 1, right? So my one full period would go from 0 to 2 pi. So now instead, it's going to go from pi to 3 pi. So my first full cycle is going to be here. That's the only difference. Of course, it's a continuous curve. We're not going to just start here and never stop and then we'll go back. We're just going to, this is where my first complete cycle will go. Because we always go from 0. Sometimes we back it up. Sometimes it goes the opposite way. If it's a plus, it's going to start back here at the negative pi and go to positive pi, because the cycle is still 2 pi. Make sense?
So if it's 2 to 0 and 1 half of u set it equal to 4 pi?
Yes, because then you have to do C over B. No. C over B would say this. C over B would say pi over 1 half, I would set it equal to 2 pi. I'm going to start at 2 pi. I'm going to shift it 2 pi over. You're thinking 2 pi over B. That's period, right? That's period. This is where I'm going to start. This is where I'm shifting. We still have a horizontal shift, but because this is not units, they're angles, we call it a phase. So that's the only difference here. So we have to take into account these angles and that frequency. I'm not going to ask you to graph one. I didn't give you a graphing on the test. You have one graph that says give me the transformations, and it contains a phase shift. So you have to say phase shift, not horizontal. You have to say phase shift, and just give me where the phase shift is, C over B. I didn't ask you to graph it, but it's not hard to graph these. That's just the rule. Like, you know, your period says 2 pi over B. So your phase shift just says C over B. This is the rule for phase shift, because sometimes this is not a 1.
So what's the pi?
Because this would be C. Because what happens is, if this says 2, so think of this logically for a second. If this would say 2, I need 2 curves in 2 pi. Now my period is pi. So I can't shift it pi. I got to shift it half of that. So it would come out to say pi over 2. If you think about it logically, if I did this, okay, without this, I said I need 2 cycles in 2 pi, right? Each of my periods has to be pi. So C over B says pi over 2. Shift it 90 degrees because this is now my full cycle. That's my first cycle. So now I only want to go halfway through that. Wasn't pi half of 2 pi? So isn't pi over 2 half of pi? I got to base it off my period. So that's why we do C over B. So then I would shift it and start here, because I would need to complete 2 of these. This is different than this. Okay, so this is the guy that's telling me it's going to make a difference how many I need. If it's a half, then it's going to expand it and start it like at 2 pi. Instead of starting it at pi, it's going to start it twice as much as that, 2 pi. You always take this and you set it equal to 0, then you set it equal to 2 pi. If it goes,
that never changes? I thought they were somewhere between.
4 pi, whatever your period is. This period is 2 pi. So say my period is pi. If my period is just pi, then I would set it to 0 and I would set it to pi. It just depends on what your period is. So you, which you would have to anyway, because you would have to figure out where your pieces are going, right? Where you're going to put your little parts. Okay. And I'm not going to ask you to graph it. Just kind of know how to do these. So that if you're faced with these again, you'll see them. You'll understand them. Okay, this, how do we do with this one? We'll keep,
Yeah, you could have just used the range and the range.
I just said domain and range, no graphing?
No, that's a different page. We have that's ready for 18.
Oh, this is the same as 18? Okay. And we'll do we'll keep it this way. All intercepts are x-intercepts. Let's keep it simple. Every time I ask you to do an intercept, just give me your x-intercepts. If this translated, don't worry about the translated ones. Just keep it simple wherever it crosses your x-axis. Where it crosses x-axis. So if this was raised and it didn't touch the x-axis, you have no x-intercept. Let's keep it real simple, okay? Max and mins, these are your max and your mins. Like, these are the points that you have to use to graph. So those are the points that you're going to need to know anyway, right? Your zeros, your max, and your min. We'll just keep it basic. If it translates it up or down, just give me where it crosses the x-axis. And again, these are all xy points, but your x's are all angles. And I want them all in radians. Okay? Just like these.
So we don't want to say so the maximum would be
Then I would want you to write 3 pi over 2, and whatever the maximum would be at. Where's our maximum? Here. Wherever the maximums are, the minimums are, I want you to give me an angle. Which, because you work angles off of it. But give it to me in radians. Okay. If you put it in your calc, you're going to go in degrees. But if you do it up here, it should work out fine in radians. God bless. Remember, key to this is always find your period. This is major. So you're saying 2 pi over 2, which means I have to complete 1 full cycle in pi. Now, divide this by 4. These are your quadrants. Obviously, this is the guy you have to keep track of, because that's where you're going to put all your little points. So your max and your mins is going to fall off of your pi over 4s, right? And pi over 4 means just separate all these into 45s. All you have to do is count them. Watch. This is 0 pi over 4. This is 1 pi over 4. This is 2 pi over 4. Pi over 2. This is 3 pi over 4. 4 pi over 4. Pi. 5 pi. 6 pi. 7 pi. 8 pi. Whatever you do with your denominator, just count them across. So when you go to tell me where your max and mins are, just work your pattern. If they were all pi over 6, I would say 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Just count your tick marks. Your tick marks are based off of this, where your quadrants fall. Yes.
if we did the domain as negative,
That's where it should be. Your domain is always negative pi to positive. Oh, no, sorry. Negative pi to positive pi? No, that's just where you're graphing. That's your window. That's your window to graphing. Your domain for your sine curve.
was that feeling okay if I graph that instead of 0 to 2 pi?
But I want you to start at the 0, because we always start at the 0. Yeah. Because when we do this, we always start here. This is where our initial side is. And your domain for your sine curve is negative infinity to positive infinity, not your window where you're graphing. And everybody can find the range okay? This is a typical problem that I'll give you. There was one that had a different period in there, the kind you don't like with the 120s, and I changed it. So I made it a little simple because I want you to get more of the concept than I want you to pen. So I made it a little simple. Okay, what does this thing mean? Phase shift with direction. Left. So left, how many radians? Pi over 2. So all that means is this is going to be my starting point instead of this. That's the only effect this has on me. So where I find my cosine, I look for my cosine. My 1, 0, my negative 1, 0, 1. I bring it back to the 1. I multiply it by 3. These are the tick marks that I have to use. My period is still 2 pi because my frequency is 1. God bless you. Why did I equal it to 4 pi? Did it say go to 4 pi in the directions? 2 full cycles. So that would make me go to 4 pi. Or if you wanted to, you could go the opposite way. As long as you gave me 2, see where it starts here? This is 1. I need 1 more.
Why did you put oh.
I asked this one to say 2 full cycles. So this one you had to go a little further out. Just a little short of 4 pi actually. So again, you're still going every 90 degrees. So your tick marks are going to be fine here. Every 90 degrees. God bless you. Because your quadrants didn't change because your period is still 2 pi. Oh, your period is 2 pi. We just made it go 4 pi because I asked for 2 cycles.
I'm confused on what C would be used for.
That's the rule that you have to use for this phase shift because this is not always 1. So in this case where it's 1, all I'm saying to do is, we can't say we have a horizontal shift left 90 degrees because they consider those units instead of angles. So when we do an angle, we just call it a phase shift. It is the same as a horizontal shift, but we have to take into account the frequency. So the frequency of this curve is 1. So let's just do 1 cycle right now. Let's just cut this to 1 cycle right here. The frequency is 1, right? That means I have to fit this cosine curve, not here from 0 to 2 pi, but I have to just walk 90 degrees over and start it. That's all it means I have to do. If this says 2, so I do C over B. This becomes pi over 4. I have to shift this 45 degrees and start. Why? Because my period now is not 2 pi, it's pi. So if my, think with me, if my period is pi, what are my quadrants at? Pi over 4. Pi divided by 4, right? So my frequency plays a strong role in this. It's just that the last 2 we did, the frequency was 1. So it's the same exact curve, just walk me, start it, and start here. If my frequency changes my period, then I have to adjust my phase shift. Right? Does it make sense? Kinda? Sorta?
So if it says like x minus pi over 2, then you would start positive?
To the right. Yes. A lot of books you'll see, a lot of books say the phase shift, their formula is negative C over B. And when I first started teaching this, I did also. I used that rule. But because some kids are used to always just looking at the positive and negative first and say go to the right, then your negative force them to go to the left. So force them to go the opposite way. So I stay with what you guys learned already. If it's negative, you go to the right. If it's positive, you go to the left. and we just do C over B. Okay?
Does it matter if we graph 2 cycles? Or it doesn't matter?
In this one, yes, because I'm going to start this. I need to know where my starting point is. It should have started at the 0, right? So I'm going to subtract the pi over 2. So I've got to start it right here.
Yeah, I mean like my first cycle was the first one you had, but then like the second one from 3
Can go
pi-
to the negative.
Yeah.
That's fine. It can go to the negative. Yeah, the second cycle I'm not worried about, but your initial cycle has to start here. Actually, if you started it over here, well, you couldn't start it here. You had to start it. If you started it here, see how you'd be off? It wouldn't look like this one. So it makes a difference where you start it. But where the second cycle goes, I said you could do it on the negative side. A lot of kids usually do a positive and a negative. Yes.
I don't get why couldn't you just draw one curve and right?
2, because your direction said give me 2 full cycles. Yeah. Go ahead.
So if the direction said only one full cycle, and the final cycle is x plus pi over 2 equals 2 pi, right?
Yes. It goes because that's your period. Because this is 1 and that's your period. If your period was to pi, we'd set it from 0 to pi. Yeah, Lily.
For cycles means what? X plus pi over 2 equals 4 pi. That's because there's 2. That's what you just said.
Because we wanted 2 cycles.
How do you know there's 2 cycles?
In your directions, I said give me 2 cycles.
Oh.
Did I have to do that? No. I could have very easily said this is 2 pi. So you're going to end at 3 pi over 2. One full cycle, God bless you. One full cycle goes from 0 to 3 pi over 2. It's just I wanted a second cycle. And I said, I don't care if your second cycle went on the negative side, because you're still going to start. Well, this is the key. Because if you started this at the wrong place, you're going to start up here. That makes a difference. You got to start it at the right place. And then I don't care if you go backwards. That's fine. A lot of kids like to do the I like usually to do the negative side. Somehow I went to the
So on the test, if we do different periods and stuff, we can still say equal to 2 pi for one cycle and then just graph 2 different ones.
Well, here's the thing. If I ask for a full cycle and your frequency is 2, how long does it take to complete one full cycle? If your frequency is 2, so it takes pi to complete one full cycle. So I only need you to go from 0 to pi. One full cycle. If you go to 0 to 2 pi, there's no harm done, right? There's no harm done. You're just going to get 2 of those. I'll just see 2 of those there. No harm done there. As long as I get at least the 1. Okay? Yes. One full cycle is pi. If your frequency is 2 pi over b gives you 2 pi over 2, right? Try to think of it not in terms of the formula. Think of it as 2 full cycles. I need to fit 2 full cycles where I fit one of them before. So don't I have to go half the distance now? So half the distance gives me pi. Try to think of it logically, because that's what gets confusing. Because then when I throw a half at you, you say like half, what do I do with half? Half of my curve is here. I need another 2 pi to complete my curve. Then I need to go to 4 pi. Then I have to go to 4 pi. Okay? Okay. All right. This has a little phase shift here. All right, let's take this one step at a time. Okay, one step at a time. What does the 2/3 do? Vertical shrink. It's a fraction, but the numerator is smaller than the denominator. It is less than 1. So if I multiply something less than 1, I get less. I shrink. So this is a vertical shrink by a factor of 2/3. What does this piece right here mean? This is the same as 1/2 x. What does the 1/2 mean? That's my frequency. B is my frequency, is 1/2. What is my period? 4 pi. Because it means this. Think of what it means. It means I can only do half of my curve in 2 pi. So technically, don't I need another 2 pi to complete a whole curve? Right? Think of it logically. So I need my period now to go to 4 pi. If my period goes to 4 pi, I'm stretching this out. My quadrants are every 4 equal parts, right? So I divide my period by 4, and every pi I am going to make a tick mark. I didn't decide where to start yet. But every pi I am going to make a tick mark. Now, just think of this logically for a second. Here is my phase shift. Without the 1/2, I should shift every pi over 4. Which way? To the right. I should have started at pi over 4 to the right. But my curve is stretched out by a factor of 2. So now where, logically, should I start this? Pi over 2. I should start this at pi over 2. Shouldn't I? Do I start at pi over 2? When I do this formula, I want you to think about this. I'm doing half of my curve. So if I say start this, and I got to start this at the right point, I got to know where to start this because it's going to make a difference. I need to only fit half of my curve in 2 pi. So when I do this, I say C over B, pi over 4 over 1/2, which says keep change flip, 2 pi over 4. My phase shift is pi over 2. Because didn't it do twice that? Didn't I need twice the time to make the lesson? If my frequency is 1/2, don't I need twice the time to make that curve? So shouldn't I start twice the distance? It's the opposite of a shrinking down. It's the opposite of a shrink. Before we said we would start half the distance if we did 2 of them. So now we're only doing 1 of them, but it's taking double the time. I can't start it at pi over 4. This is going to play a major role in here. I got to start it here at pi over 2. Now, I said I'd go every pi. So here's my tick marks. I took care of my amplitude change, and I'm going to start here at the 2/3. Like, just estimate where it is. Then I'm going to come to the 0. How do I know where to go? Every pi units. So if this is pi over 2, add 2 pi to this. Just keep adding 2 pi over 2. 2 pi over 2. Just to your numerator, just keep adding 2 pi. So this will put me at 3 pi, then at 5 pi, then at 7 pi, then at 9 pi, then at 11 pi. I don't care what those angles are. I just know this is the pattern I have to follow. I'm not going to start at the 0. I'm going to start here. And I'm going to go every pi radians, every pi, I make a tick mark.
Why do you do that?
Because we said if your period, okay, if originally I did my cosine curve like this, and I have no shifts, where would I start? At the 0. And I would follow the 1, the 0, the -1, the 0, the 1, right? Don't worry about the amplitude change. So when I do this, this is going to take me half of my cycle. So my period is going to be 4 pi. So every pi is where I make a tick mark. So I would have started here. I would have went to pi. I would have went to 2 pi. Isn't that half of my curve? So now I still have to go every pi, right? So if I start at pi over 2, that puts me in a weird spot. How do I go every pi? So pi in terms of 2, if I do this, don't I make this like this over 1, and I say, isn't 2 pi, oh, sorry, over 2. Isn't 2 pi over 2 the same as pi? So technically I'm adding 2 pi over 2 each time. So since your denominator is halves, just add your numerator. Just keep adding 2 pi to your numerator. So 1 pi, then at the 3 pi, then at the 5 pi, then at the 7 pi, then at the 9 pi. Isn't that pi distance apart? Allie?
I somehow like graphed it right, but when I found, like I did like the x over 2 minus pi over 4, I set it equal to 0 and 2. Somehow I still got.
And you'd still have to go this because you still had to get your full cycle in here.
Yeah.
You went up to here.
Yeah, and then I just did the negative.
And you did the negative, that was fine.
Shouldn't it not work like 1 cycle because this is the frequency or the period 4 pi?
The period is 4 pi. You should have went from here to here. This should be 1 full cycle.
Yeah, that's what I have. But
Mm-hmm.
how how did I get 9 pi over 2 when I set it equal to 2 pi?
9 pi over 2, if you did, I set mine equal to 4 pi. If you did set yours equal to 2 pi, that is right here at 9 pi over 2. That is one full cycle. I just asked you to do 2, so I doubled mine.
Yeah.
Oh, no, I see what you're saying.
I thought.
Here's my 2 pi. 9 pi over 2 is not 2 pi. This 9 pi over 2 is 4, a little bit more than 4 pi, isn't it?
Yeah, but like I set it, like to get like a start and the end, I set it equal to 2 pi.
You set this equal to 2 pi, x over 2.
No,
Okay, so let's see what you did. So you added pi over 4,
yeah.
and so you should have gotten, this should be 8 pi over 4, so you got 9 pi over 4,
Yeah. Oh.
and x over 2, 2. Then you're going to have to multiply this by 2, so this should be 18 pi over 4, which is 9 pi over 2. So you got the first cycle.
Yeah, I just feel like, because I thought to get the first, like, the one cycle, you had to set it equal to the period. 0 and then equal to the period.
Yeah, but you took care of your period because you did this. You did x over 2, so you multiplied it by 2, which says double that. When you do this, you multiplied it by 2. That's what you did there. Okay, so are we good at this?
Nope. Yeah. Somewhat.
Can you just leave it on?
No, we don't have to have one like this on the test, right?
You're not going to have one like this on the test, but I do want you to understand how to do this. The problem with you guys is you have to think this out logically. So rather than say, what is that? I would say, I got to get half of my curve in 2 pi. I got to start it at someplace other than 0. If this had no half, I would start mine at negative pi over 4, right? But now I'm expanding this. I'm taking twice the space to put my tick marks, aren't I? I'm not going every pi over 2. How far am I going before I make a tick mark? Every pi. So therefore, instead of starting at pi over 4, shouldn't I also double that and start at pi over 2? I have to expand everything the same way. So even without doing your formula, you should be able to catch that. If I'm doing half of my curve, I need twice the room, twice the space. So don't start it with this little tiny angle. Double that, because I'm stretching this out on you. If I have a 2, I'm shrinking it in. So then I wouldn't start at pi over 4, I'd start at half of pi over 4. I can fit 2 of these guys. God bless you. I want you to think logically. All right, I'm going to move on just because we have to, how many more do we have of these? One more? Okay. Okay, I want to get to those. And again, the phase shift, I'm not having you graph the phase shift, but I do still want you to understand this. Now, before you look at this, let's think this logically. Okay, logically. How many curves in 2 pi? 2. Right now, if it was 1, where would I start this? At negative pi. But I need to have half of that distance of 2 pi, don't I? So, wait. I need to have half of that distance. How long is my period if I put a 2? Pi. Everybody look at me. I need to have half of that distance now. I need to go to pi. So don't I need to start this at half of that distance? So where should I start this? Negative pi over 2. Negative pi over 2. Doesn't C over B say pi over 2? But doesn't that make sense? I need to put 2 of these things now. Now my period says shift this. I need to change this. So if I need to put 2 in there, aren't I using everything half the space? Half the space. So I should take half the space of this to start. That's what my C over B does. I take half that space.
I thought you said you always start at 0.
Not on a phase shift. Not on a phase shift. Not on a phase shift. Yes, we would start at 0 without a phase shift. Yes. We start, don't get me wrong, Amani, we start this at 0. Maybe this is what you're thinking. That's what we start at 0. Where's my first shift going to be? Sorry, that came out. My board is way off up there. This is where I start at 0. So are we good with this? I don't want you to get too hung up on the phase shift part. But I want you to think it out logically. It makes sense. This one did make sense? Because it doesn't have a fraction in it. I get it. That's your guy's problem. I had 2 fractions in the other one. Of course you panicked. You saw 2 fractions and you said, oh no, fractions. So, long story short, one second. I want you to find me all your x-intercepts. Give it to me like a xy point. Use your angle. I want you to find your max and your mins. Okay, in radians. Question, Ellen?
So it'll work if you just like define like the start and the end point for one cycle. It'll work if you just set everything in parentheses to 0 and then 2 pi.
2 pi.
So you don't have to worry about like setting it up.
Well, the only time I did the other one because I said do 2 full cycles.
Yeah.
I said 4 pi.
Yeah. So
Just
I
go
usually
0
just
to
find
2
one.
pi. Yep. 0 to 2 pi. And actually, as soon as you start graphing it, you'll see your full cycle.
Yeah.
You should see it.
I put the cycle idea as true, but shows
So as I made you do 2 cycles, I just kept going with it. I just did it again. Just follow your cycle again. Only because I said graph me 2 full cycles. Could you graph the other side into the negatives? Absolutely. But the key here is where did you start making your curve? The phase shift counts. Okay, so what was the other thing we had?
Domain and range.
Domain and range. You going on the
Yeah.
Okay, have fun. I need you to be able to do these. So I need you to start again. So start with what is tangent? Tangent says real numbers except for x equals n pi over 2, where n is any odd integer. Okay, start like that. Take this guy and put it equal to that x. That's all you have to do. Don't worry about an amplitude, especially on a tangent. So just take this guy and set this equal to this. Because now I'm not using x, I'm using x over 2. And x over 2 means what? Half, half, that's my frequency, half that curve in our tangent was pi. So now our tangent period is going to be 2 pi. But I don't care about that part right now. I just want you to just take this and set this equal. The denominators are equal. So, think of this logically. Didn't the tangent every n pi over 2 odd ones had an asymptote? Now, if I double that, if I have to make double the space, doesn't it mean I double where my asymptote goes? So instead of every pi over 2, every 90, aren't I going every 180 to make that asymptote? I know it has a fraction, but the fraction works the opposite way here because you're doing half of that space. So my tangent is going to say this. Instead of that 90, because here was my beloved tangent curve in here, but I said it's going to take me twice as long to make this curve. It's going to go from here to here. So it's going to go here. So now here's my asymptote. So doesn't that make sense? I changed the period. I have to do half of my curve now in pi. It's going to take me 2 pi, but tangent is centered at the 0 here. And so this totally makes sense to me. And then you're going to bring this down. Now don't fall into this trap. This is not your domain. Because sometimes we don't rewrite this. You have to rewrite this. Sometimes we get that far and we say, okay, I did it. And I just draw a little arrow here and she knows what I mean. You have to say real except where x is equal to n pi, where n is any odd integer. Just say real except. Okay, do the same as you started this. All I need you to do is put it back together. You were just missing this piece here. And that's just one of those places I see kids forget to put the rest of it. And your range is not affected by an amplitude change on your tangent, so don't worry about any amplitude changes. It just kind of sharpens it up a little bit, but it's okay. Your tangent range is all real numbers. Because your tangent, it's like a little piece of spaghetti here. Yeah. It's a chunk. It's not a continuous curve. Okay, cosecant and cotangent work the same. You only have two to memorize. The C's work the same, and the tangent and the secant work the same. They kind of go back to that Pythagorean theorem one, where they're kind of grouped together that way. So this says n pi, where n is any integer. So all I need you to do is set this 2x equal to whatever that x is equal to. It used to say x equal, well now it's got to say 2x equals. So logically this says I'm only doing this in half the time. So now I should cut this in half, shouldn't I? And isn't that cut in half from pi, every pi to every pi over 2? Isn't that cut in half? Think of it logically. I know you've been hesitating to do that because it's still new and you're saying, I don't know what she means. But try to think of it logically. If I need to fit two of these curves, and if I ask you to graph this, can you graph this for me? Because you're going to see one like this. So you can graph this. How would you start graphing this?
1/2 sine 2x.
Very good. So Chris would make it 1/2 sine 2x. He'd graph the sine curve first. You'd put your asymptotes where? At the what? At the zeros. Clearly label your asymptotes and don't forget to make your little u's. So here's my sine curve. I'm going to make two of these. And I'm going to 1/2, so pretend this is 1/2 up here. 1/2, 0, negative 1/2, 0, 1/2, 0, negative 1/2, 0. Okay, I need two of these, right? And I can go the other way, whatever. Make these guys be your asymptotes. Clearly define your asymptotes. That's what this is. Those are those exceptions. They define your asymptotes. And look, they are going at every 90. 90, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And don't forget to make your curves go like this. That's another thing kids forget. They spend so much time making all this graph and they forget to put their reciprocal graphs on there. It happens. I do the same thing. I spend all my time doing everything else and not get to that. You okay with that? Okay. And what else? We have one more? Secant. Okay. This, again, I'm not going to ask you to graph this, but I will ask you just to set it equal to that. And x is equal to n, where n is odd integer. Don't forget, these are still in radians. All right, if you want, I've got an extra worksheet. I made it in case we worked today in class. I would not graph the first page. I would graph the two on the second page and look up and do the two formulas. What I'll do is I'll put this on the website. I'll put the answer key on the website. So then hold on. I'll put the answer key at the end.
I have a question on the transformation.
Okay.
What exactly do you want us to put when there's like a
Phase shift. I want you to say just that. Phase shift. Phase shift left. Right. Higher to right. Higher to. Yeah, but just don't say horizontal shift because we're not shifting units. So we say phase. Kind of like I wouldn't graph the first page. Don't do the first page.
I never really know who it's like. It's something the one that looks weird. It's like a